Welcome to our deep dive into cloud computing. In its simplest form, cloud computing means accessing digital services like storage, databases, or applications through the internet, instead of running everything on your own hardware. It's a flexible approach, enabling individuals and organizations to tap into computing power whenever they need it. Right here, in just a few moments, you've got the core idea. The cloud is about convenient, on-demand resources managed by someone else's servers. But how do these remote resources revolutionize modern business, technology, and daily life, and what breakthroughs are on the horizon? Stay with us as we unpack the nuts and bolts of cloud infrastructure, reveal top providers, and explore cutting-edge innovations like edge computing and serverless architectures. By the end, you'll not only understand how the cloud simplifies operations and scales with ease, but also how to harness its power for your own projects. Let's begin by really pinning down what cloud computing entails. Traditionally, if you needed computing power, you'd buy physical servers, maintain them in your data center, and handle every aspect of their upkeep from cooling and energy consumption to security and system updates. In contrast, cloud computing is like renting a well-equipped facility that's always ready for you. You can remotely deploy applications, store data, and run complex workloads without tangling yourself in hardware logistics. Imagine you're a small startup developing a mobile app. Instead of purchasing expensive servers up front, you can use a cloud provider's virtual machines and pay only for what you actually consume. If your user base suddenly doubles, you won't need weeks to buy and install new hardware. You simply upgrade your subscription or allocate more virtual resources in seconds. The same goes for storage. There's no need to guess how many hard drives you'll require next year because the cloud offers near infinite capacity on demand. Moreover, many cloud providers include specialized tools such as analytics platforms, machine learning frameworks, and robust security features, ready to integrate into your projects. This model dramatically reduces the overhead of running your own infrastructure, freeing developers and businesses to focus on innovation rather than maintenance. In short, cloud computing streamlines both the cost and complexity of delivering digital services to users worldwide. To fully appreciate the cloud, let's explore its main service models: IaaS, PaaS, and SaaS. First, Infrastructure as a Service, IaaS, gives you raw computing components, virtual machines, storage, and networking. It's like having a virtual warehouse where you can set up your own operating systems, deploy applications, or even create entire networks in software. You're responsible for installing and managing the operating system and everything above it, but the physical hardware itself remains off your plate. Next, Platform as a Service, POS, builds on this foundation by offering you a pre-configured environment, complete with an operating system, development tools, database services, and more. If you're a developer looking to write code without fussing over server setups, PaaS might be your best friend. It streamlines deployment by handling the underlying OS, runtime, and essential security updates automatically. Imagine logging in, writing your application in a web-based IDE, and instantly having it run in a production-ready environment. Finally, Software as a Service, SaaS, is the fully packaged experience. Think Gmail, Salesforce, or Microsoft 365. End users simply access these applications through a browser or dedicated client. There's no need to install or update software locally because everything runs in the cloud provider's infrastructure. This convenience makes SaaS offerings popular among both consumers and enterprises seeking quick, user-friendly solutions with minimal overhead. In the cloud computing ecosystem, a few big names stand out: Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS was among the first to popularize on-demand cloud services, offering an extensive catalog that spans data storage, AI-driven analytics, Internet of Things functionality, and beyond. Their global network of data centers is designed to provide low-latency access anywhere, making it a go-to option for businesses that need worldwide coverage. Meanwhile, Microsoft Azure has leveraged decades of expertise in enterprise software. If you're already entrenched in the Microsoft ecosystem using Windows Server, SQL Server, or Active Directory, Azure offers tight integration that can ease your migration to the cloud. Their platform also supports a vast range of open-source technologies, so you're not locked into Windows-based tools exclusively. Azure's focus on hybrid cloud solutions means you can seamlessly mesh your on-premises servers with cloud-based components, ensuring a gradual and flexible transition. Google Cloud Platform boasts some of the most advanced big data and machine learning services, stemming from Google's background in search and data processing. GCP is especially appealing for AI and container orchestration, thanks to its direct involvement in developing Kubernetes and TensorFlow. Beyond these giants, there are niche players like IBM Cloud, Oracle Cloud, and DigitalOcean, each catering to specific markets or specialized workloads. The competitive landscape ensures continuous innovation, so users benefit from new features and cost optimizations over time. One of the standout advantages of cloud computing is its scalability. Picture an online store preparing for a holiday sale. The traffic might quadruple overnight, but with the cloud, additional virtual servers can be spun up automatically to handle the load. When the sale ends, the infrastructure scales back down, preventing unnecessary costs. That elasticity means you're always right-sized for demand. Cost efficiency is another huge draw. The pay-as-you-go model frees businesses from hefty upfront investments in hardware. Instead, you pay for what you use, no more guessing how many servers you'll need next quarter. This model also makes advanced technologies like AI-driven analytics or high-performance computing accessible to smaller organizations that previously couldn't afford powerful on-premises hardware. On top of that, cloud platforms provide a global reach. With data centers spread across continents, you can deploy services geographically closer to your customers, reducing latency and improving user experience. This is critical for streaming services, real-time gaming, or any application where milliseconds matter. Plus, having multiple data centers around the world allows for redundancy. If one region suffers an outage or natural disaster, traffic can reroute seamlessly to another region, keeping your services online. Whether you're a tiny startup or a multinational corporation, the cloud gives you the means to operate with resilience and efficiency on a scale once reserved for tech giants. Of course, cloud computing isn't without its hurdles. Security is often at the top of the list. When your applications and data reside on someone else's infrastructure, you rely heavily on that provider's security measures, encryption protocols, firewall configurations, access controls, and so on. While major providers invest billions in cybersecurity, you still need to configure your cloud environment properly. Misconfigurations like leaving an S3 bucket publicly accessible can lead to data breaches. Hence, understanding shared responsibility is crucial. The provider secures the underlying hardware, but you're responsible for securing your applications and data layers. Vendor lock-in is another concern. Cloud ecosystems can be sticky, offering proprietary databases, AI services, or deployment pipelines. These can boost productivity in the short term, but if you ever decide to switch providers or move back on premises, you might face complex migrations and hefty data transfer costs. Strategies like using containers, open-source technologies, or multi-cloud setups can help mitigate this risk. Finally, even the biggest players experience downtime. Outages, though rare, can disrupt services for hours or even days, causing lost revenue and customer frustration. A robust disaster recovery plan spreading workloads across regions or multiple providers can reduce your exposure to a single point of failure. Balancing these challenges with the cloud's benefits is part of every organization's strategic planning. As the digital landscape evolves, edge computing is emerging alongside the cloud. In this model, data processing happens close to the source, like in local edge devices or mini data centers, to reduce latency and bandwidth usage. Consider self-driving cars that need real-time image recognition. Shipping every frame to a distant cloud data center introduces delays that could endanger passengers. With edge computing, critical decisions happen locally, while the cloud handles tasks that require massive storage and long-term analytics. We're also seeing a rise in hybrid cloud setups, where organizations keep some workloads on premises and place others in the public cloud. This is especially useful when regulations require certain data to remain in a specific location, or when legacy applications aren't easy to move. Hybrid deployments let you modernize parts of your stack without overhauling everything at once. Looking ahead, multi-cloud strategies using services from different providers are becoming more common. A company might use AWS for machine learning, Azure for Microsoft integrations, and GCP for big data workloads, optimizing each segment of their infrastructure for cost, performance, or compliance. Beyond that, developments in quantum computing and next-gen networking will likely integrate with cloud environments, pushing boundaries of what's possible. The cloud we see today is just the foundation for even more transformative technologies. If you're considering migrating to the cloud, start by conducting a thorough audit of your existing infrastructure. Identify which applications are best suited for the cloud, typically those with variable traffic, heavy compute demands, or global user bases. Determine which workloads might remain on-premises for compliance or cost reasons. By prioritizing certain services for migration, you can test the waters before moving everything at once. Performance testing is your next step. Spin up cloud-based development or staging environments to see how your app behaves under load. Tools like load balancers and auto-scaling groups are essential for distributing traffic and ramping capacity up or down. Evaluate the available storage options: 2-block storage for databases, object storage for unstructured data, or archive services for long-term backups. It's also important to manage access and security diligently. Leverage identity and access management (IAM) solutions to create fine-grained permissions. This ensures each team member or application only touches the resources they actually need. Encrypt sensitive data both at rest and in transit, and keep a close watch on logging and monitoring. Services like AWS CloudWatch, Azure Monitor, or Google Cloud Logging provide real-time visibility into system performance and potential threats. Finally, establish clear cost controls. Many providers offer budgeting tools and alerts so you can track usage, catch unexpected spikes, and optimize spending. Being proactive prevents unpleasant billing surprises, especially when experimenting with new services. Beyond basic hosting and storage, the cloud unlocks advanced capabilities. Machine learning services like AWS SageMaker, Azure Machine Learning, or Google Vertex AI allow organizations to build predictive models without managing underlying GPU clusters. This can accelerate research in fields as diverse as healthcare diagnostics, financial forecasting, and supply chain optimization. Serverless computing, exemplified by AWS Lambda, Azure Functions, or Google Cloud Functions, pushes abstraction even further. Here, you simply write functions that run in response to specific triggers, such as an API call or database update. You're charged only for the compute time used during execution, making it highly cost-efficient for event-driven applications. Plus, you never have to worry about provisioning or patching servers in the background. Containers are another game-changer, letting developers package applications and dependencies in lightweight units that can run consistently across environments. Tools like Docker and Kubernetes have become standard for orchestrating microservices, scaling them horizontally to accommodate surges in demand. Imagine you have dozens of microservices each for a different feature of your platform running in containers that automatically spin up or shut down based on real-time usage. This microservices approach promotes rapid development, easier updates, and higher fault tolerance. Whether you're exploring advanced analytics, pushing the boundaries of continuous integration, or experimenting with serverless APIs, the cloud's robust ecosystem is designed to streamline these modern development paradigms. To wrap up, cloud computing is no longer just an option, it's the backbone of countless digital services we rely on every day. From small startups seeking agility to enterprises aiming for global scale, the cloud's flexibility and power are hard to ignore. But here's the deeper insight: combining the cloud with edge computing, AI, and containerized deployments can supercharge innovation even further. Embrace these tools and you'll be poised for the next generation of digital transformation. Thanks for watching.